Okay, this is Math 2, and we're going to be doing problem 55 first in Chapter 5, and then we'll see how long that takes me. If I'm past 15 minutes with just one problem, I might just do another video for the other one. So, let's see. Lots of dough. Lots of dough. That's funny. A wealthy customer would like to order a variety of parabolas. However, he's feeling pressed for time. He's going to pay you lots of money if you complete this order for him. Of course, you agree. Determine the positive equation for each parabola, so you pass the information on to the function factory. So, let's see the first one. We have two x-intercepts. We don't know where the y-intercept is, but it might be somewhere down here. Well, it is somewhere down here. We just don't know what the number is. But we have two x-intercepts, and we know it opens up. So that should give us enough to go on. So one of the x-intercepts is -4. The other x-intercept is +2. So working backwards, this would have been x plus 4 equals 0, and x minus 2 equals 0. And we're going to multiply these together. And we should get, after you do a box, you should get x squared plus 4x minus 2x minus 8. That should be what you should get inside the box. So you end up with x squared plus 4x, plus 2x minus 8. And since you don't know where the y-intercept is, I mean, it could be at -8 for all we know, because we don't know what the scaling is on the y-axis. All we have are numbers to go by on the x-axis. So I'm going to stop it here. And it's a positive value, positive coefficient on front of the x squared, so I know it's got to go up. So I might say, yeah, that might be a -8. Okay, we're done with A. All right, part B. You can't actually see it, but part B still has two x-intercepts. It's just they're both actually just sitting at the same time on top of each other. So this is x equals 3 and x equals 3. And we have x minus 3 equals 0, x minus 3 equals 0. So that means we have x minus 3 times x minus 3 equals 0. And if we do a box for this, we should end up with x squared minus 3x plus 9 equals 0. And that gives us x squared minus 6x plus 9 equals y value. So there's our equation. And it could be that this actually hits it at 9. We don't know. It's not drawn to scale. So we're good to go. Okay, that was part B. Same thing for part C, but this time you have x equals 0 and x equals 7, right? So you're going to do the same thing and get an equation. Your y-intercept should be 0, so you should be left with plus 0 on the end, or it shouldn't be there, either of the two. And then part D is the one that's upside down. So we have x equals, let's see, x equals -5, x equals 1, so we have x plus 5 equals 0, x minus 1 equals 0, and then we have x plus 5 times x minus 1 equals 0, and then if you do a box, that should give you x squared plus 5x minus 1x minus 5 equals 0, and then that gives us x squared, what does it give us? Plus 4x plus 5, minus 5 equals 0. Okay, so right away I know I have a problem, because this minus 5 for the y-intercept is obviously not up here, right? And on top of that, this is going upside down, or this is opening down. And the coefficient on my x squared is a +1. So the way we fix this is since we want the coefficient on the positive to be a negative, right? Because otherwise that's what's going to tell us the parabola is opening down. So we're just going to multiply everything by -1. So that'll give us -1x squared minus 4x. Why did I do a y right there? That's weird. Okay. Plus 5 equals y. And now I know for a fact this is, probably going to be a positive 5 to match the C value on the equation. And we're done with 55. Okay, next. 56 is, on graph paper, make a complete graph of x squared minus 2x minus 8. Fully describe the graph, which basically means it wants x-intercepts, y-intercepts, and the vertex. That's the best way to say it. So we're going to factor this first. So we want the x-intercepts. What are they? What's the y-intercept? And then what's the vertex? Let's see. And which way does it open? Up or down? That's what we really also want to know. Okay, well, I know the y-intercept right away since it is in standard form is 0, -8. And I don't know anything else besides that, so I'm just going to factor this thing. Let's see, I have an x squared, I have -8, so I'm looking for -8x squared. Two numbers multiplied to -8, but added together give you -2. 4 and 2, -4x and 2x. Yep, that works. Okay. So that's got to be -4. That's going to be a +2. This, that, this. Okay, so that works out. Oopsie. So then 0 equals x plus 2 and x minus 4. So x plus 2 equals 0. X minus 4 equals 0. So x is equal to 4. X is equal to -2. So -2, 0, and 4, 0. I still don't know where the vertex is, though. Okay, I need to graph this. Alrighty. So we have a couple of points to graph. Okay, so what do we have? -2 and 0. And then 1, 2, 3, 4 and 0. 1, 2, 3, 4, 5, 6, 7, 8. This is my y-intercept. Okay, so that means my vertex has to be somewhere in the middle between -2 and 4. There's the -2 and there's the 4. So I gotta go somewhere in the middle. Okay, well, let's see. So this is the middle. Right, somewhere in between here. Right, so my vertex is going to be somewhere in the middle of this line. Okay, well, I can figure out what that number is, obviously, because it's +1. So I'm going to take the +1 and I'm going to plug it into the actual equation. So I get y equals 1 squared minus 2 times 1 minus 8. So y equals 1 minus 2 minus 8. So y is equal to -2. Wow, that was horrible. -1 minus 8. So y is going to equal to -9. Okay. So for my vertex, I have +1, -9. Right? Because my number 1 is going to come from the x's. And then I take the 1 and I plug it back into the equation. I have -9 as an answer. So that means my vertex, the bottom point of this, is going to be at 1, and that's -9. So my whole equation, or my whole graph, is going to come down this way, like that. And then come back up again, and go off in that direction. There you go. There's your graph. Okay. All right. Next and last one. On graph paper, make a complete graph of the line y equals 3x plus 1. What is the slope angle? What is the acute angle that the line makes with the x-axis? Oh, we have to find theta. Write the equation of the line that has a slope angle of 45 degrees. Passes through 0, 3. Assume the slope is positive. Solve for the intersection of two lines using any method. Write your solution in form xy. Okay. This should be interesting. Okay, no, I don't want this marker. I want the green one. Hopefully this will come out okay. Okay, 3x plus 1. Okay, so 3x plus 1 looks like plus 1, so we gotta go 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, and then we're going backwards because this is a full line. But, oh, it only really wants it to make an acute angle with the x-axis, so we just gotta work it out. Okay, so wow, okay, this is interesting. Okay, I'm just gonna go up to here, and I'm just gonna do that. So this is y equals 3x plus 1. Starts at 1, your slope is 3 over 1. Okay, well, I really don't have a choice here. So we're going to have to pretend we're going to bring up the x-axis kind of up here. This is the pretend x-axis, even though that's the real x-axis. So the question is, what's this angle in here? So what we really want to know is the slope triangle right here. Okay, it has, I'm going to zoom in really quickly. It has a vertical change of 3, has a horizontal change of 1. And the question is, what is this angle right here? So we're technically trying to find theta. So we're going to set this up. This is your change in y. This is going to be your change in x. So that means we're going to use tangent. Tangent of change in y, right? Tangent of theta. So tangent of theta is going to be 3 over 1, because it's change in y over change in x. So that means inverse tangent of 3 over 1 is going to be my theta. And then I go to my handy dandy calculator. Oh, where's my handy dandy calculator? Ah, I'm stuck. Okay, so on my handy dandy calculator, I'm going to do inverse of tangent, 3 divided by 1, and I get 71.56. So I'm going to round that to about 71.6 degrees. Okay, so this is, so theta, so this angle in here is going to be 71 point, so around 71.6 degrees. Okay, so that's the first part. That's part A. Part B says, write the equation of a new line that has a slope angle of 45 degrees and passes through the point 0, 3. So, oh boy. A slope angle of 45 degrees. If you go back to your trig table that we were doing, this slope angle of 45 degrees has a change in y and a change in x of 1 over 1. So technically, we don't really need to do too much to this one. So we're gonna, this is from your the trig table that we did the first time we started doing change in y over change in x. So this was equivalent to 45 degrees. So go back over here. So we have, it hits it at 0 and 3, so 1, 2, and 3. And it's going to basically just go up 1 over 1 every time. So up 1 over 1, up 1 over 1, up 1 over 1. So a line, basically that goes like this. Okay. Has a 45 degree angle right in here right in this angle right in here, has a 45 degree angle in there. And your slope is going to be 1 over 1, 1 over 1, 1 over 1 every single time. Okay. And that is the line of y equals basically 1 over 1x plus 3. That's your equation. And then the last part is, where do they intersect? Okay, well, there you go. You can kind of see where does the blue line and the red line intersect each other. Okay, and that is it for those 3 problems. If you have any questions, you can see me later.